Okay, let's go to the modules. Okay, hypothesis testing is our lesson for today, and then testing about a proportion and about a mean. So I want you to look at our lessons until the end of the year or end of the semester. So after this one, we're going to talk about testing of two population in chapter 9, and also interval of two population. In chapter 10, we're going to talk about correlation and linear regression, which you already did a little bit at the beginning. So it's not a very long lesson in chapter 10. Chapter 11, 12 are about testing as well, goodness of fit and contingency table and one-way ANOVA. So basically for the remaining of the year, all we have is about testing or finding interval. And we're going to use all those calculator commands that I showed you on their stat. Okay, so let's just start with 8.1. This is about basics of hypothesis testing. So we quickly go over that because in 8.2 and 8.3 we go to the details. And we don't go over 8.4, that's not part of the curriculum of the course. Okay. So the key concept here, we're going to talk about formal hypothesis test, about the concept, and then how we apply that to hypothesis test involving proportions and means. We don't go over standard deviation or variance, just proportion and mean. Okay, so I want you to write down these definitions as we go. So this page is about hypothesis. I'm going to give you a minute to read it first, write it down, and then I'll go over that. So write down these two definitions. Okay, hypothesis, and then a hypothesis test. Hypothesis is a claim or statement about a property of a population. So you're making a claim about property of a population. So you are using sample, but what you are claiming is going to be about population. A hypothesis test is a procedure for testing that claim. So I want you to pay attention to the word population, and then hypothesis test is a procedure of testing a claim about that property. So let's look at an example. Here we go. Can I ask a volunteer to read this, please, for drone deliveries? Anyone? I don't want to be the only person talking in this room.
I read.
Thank you, Andrew. Go ahead.
Example, majority of consumers are not comfortable with drone deliveries. 1,009 consumers were asked if they are comfortable with having drones deliver their purchases, and 54% or 545 of them responded with no. Using P to denote the proportion of consumers not comfortable with drone deliveries, the majority claim is equivalent to the claim that the proportion is greater than half, or P is greater than 0.5. The expression P is greater than 0.5 is the symbolic form of the original claim.
Thank you. So, claim here is, so they gave you some numbers. They said 54% of the sample responded that they are not comfortable with drone deliveries. So, what would be your claim? Your claim would be majority are not comfortable, or greater than half are not comfortable with drone deliveries. So that's your claim. Then you're going to, based on your sample, you're going to test the claim and say if that's true about the population or not. So just this 54% is not enough to tell you that this is a majority, because that's for the sample. You're going to do the procedure of testing to see if that's majority for the population, if that makes sense. So for now, just keep in mind 54% is for sample. Our claim is majority or more than half. More than half are uncomfortable, or they are not comfortable with drone deliveries. Okay. So now we're going to talk about testing. When we start testing, we use the sample, and we're going to see if that's significant to just say that that's true for the population. It's a majority for the population or not. Otherwise, if you could have judged by sample, then the whole procedure here would have been unnecessary. But we do the procedure of testing because we use sample to conclude for the population. Okay. Oops. The big picture, we have the claim that P, which is population proportion, is greater than 50. We make a claim about population. And then we are using that claim supported by our sample, that among 1,009 people, 54% said that they're not comfortable. We want to know if that's significantly high, that they are not comfortable, and we're going to use our calculator for that. And we're going to get to p-values. Let's write here. Let's write here. They said the number was how many? 545 out of 1009. So let me tell you something. Grab your calculator because I don't want to just go further without telling you how we are utilizing our calculator here. So open your calculator or bring your calculator until I open this. This is about one proportion. Oh, shoot. I have to use it. This is about one proportion, and you are testing. So you're not talking comparing two population. You're having one. Go to, let's clear everything. I'm going to clear this. I'm going to clear this. Okay. So as I said, for the remaining of the semester, stat and tests are your most commonly used tab. So you go all the way down. Which one do you think is the one that we're going to use? One prop Z test. Do you see here? You're testing a population, and that's about proportion because we said 54%. It says, what is P naught? I'm going to explain to you in a second how we write all of these. But in this case, P naught is always your claim. You say majority more than half. So you put half, and more than half is using greater. Then you say 545 out of 1009. So I'm going to explain how these would work. I want to show you p-value right here, but our claim was majority more than 50%. If you see, I highlighted more than, and I put 50% there, 0.5. X is partial, 545, and N is 1009. So you go calculate. Do you see prop greater than 50? So that's your claim, the first sentence. Yep, I said P greater than 50%. Z value is just test the statistic. We don't use it much unless they ask to write it out. But we really always need this, which I'm going to explain in a second through PowerPoint and examples, that this is P value. P value is what we get out of testing. If P value is small, we support our claim. If P value is large, then we do not support our claim. Someone might ask here, how do I know if this is a small or not? If they don't give any number, we compare that with 5%. So this number is 0.0053. We compare it with 5%. Sorry, my pen is acting. We compare it with 0.05. If this number is a smaller, then we call it a small. If this number is larger, we say large. So as I said, for comparing decimal, you go digit by digit. This is 0, this is 0. This is 0, this is 5. So yes, p-value in this case is a small. So if p-value is a small, then we know it's significant. Then we know we support the claim. So we would say there is enough evidence to support that majority of people are uncomfortable with drone deliveries. Okay. So we started from sample. When we wrote it out, we said there is enough evidence to support that majority of, when we say people, we talk about population, whoever they are. Majority of our population are uncomfortable with the drone deliveries. So that's gonna be our lesson, pretty much for 8.2 or part of 8.2. Okay, so now I just wanted to show you that where we are going in general. Let me go back to the PowerPoint. Okay. We use technology and we use calculator here. And do you see we use TI? And this was test the statistic disease given, but we use P to judge the P value. So that's the technology we're gonna use. Okay. I want to give you a minute. Just read this page and I'm going to page to the next.
Professor, when I plugged it into my calculator, I got different numbers.
We're going to go through them, but what did you put 0.5 for the first line?
I did, and then I got z equals -5.3, and then p equals 7.9,
Let's
and
go
then
back
n
to your entry. Let's go back to
Okay.
your entry again.
I just want to make sure it's on my calculator.
No, all calculators will have the same outcome.
Okay, so yes, stat, and then I went to tests, and then number 5, 1 prop z test. Okay, and then 0.5, 545, 1009, and then I went to calculate, right?
No, go to the third option where it's greater because we said majority.
Oh, that's what I did. Okay.
Yeah.
That's what I did. Okay, thank you. That's what I did wrong.
Yeah. We focus on understanding of how the hypothesis testing procedure works and learn the associated terminology. Okay. So we're going to talk about test of significance where p-value itself, when it's a small, means it's significant. When p is large, that means it's not. Two concept or two vocabulary words that we're going to use throughout the next few chapters: null hypothesis, alternative hypothesis. Null hypothesis is always equality. Alternative hypothesis is greater, less, not equal to. In this case, the null hypothesis was P, because it's about proportion, is equal to 0.5. Alternative hypothesis is P greater than 0.5 because they said majority. So null is always equality of whatever is the alternative. And then greater, the next one is greater. So null, always equality, proportion equality, and then alternative is proportion. And in this case, they said majority means more than half, so greater than 0.5. Okay. Null hypothesis is a statement that the value of a population parameter, that could be proportion, that could be mean, and then we don't deal with the standard deviation, is equal to some claim value. Always equality. Alternative hypothesis, we show it by A1, H1, HA, or HA. Give me a second, please. Hold on a second. Okay, alternative hypothesis, we denote it by H1, HA, or HA is a statement that it's talking about parameter, but then it differs from the null hypothesis. Means alternative is never equality. Is either less, greater, or not equal to. So one of these symbols. Less, greater, or not equal to. So it has to be one of these. So means whenever you're claiming that greater, less, not equal to, even if you claim that, oh, the population proportion is equal to 20%, then let's say that the population proportion is equal to 20%, you need to use inequality or inequality of not equal to for alternative. So alternative must be one of the three signs, bottom line. Okay, please note that as well. So here's a procedure. I'm gonna basically summarize that when we go to problem. But we mainly need to identify the claim, read the question well, see what is the claim. And then we must write down correctly what is the null hypothesis and alternative hypothesis. Significant level alpha, we said if nothing is given to compare, you compare with 5%, but they tell you if it's 1% or any like 10%. So that's given, but that's alpha. And say alpha is 5% means compare with 5%. Okay. Identify the test statistic. So you find the test statistic depending if it's Z, T. For majority of cases, this is just as part of the question they ask you. But the larger the Z, the more significant. So the smaller than the P. So you remember we said like if Z is more than 2 or less than -2, out here is significant. So that means that associated with a small p-value. So normally large p-value, large z's associated with the small p-values. Okay. So let's go down. We don't need, if anywhere in your questions, and I said on the announcements too, part of the questions will ask for critical values. I try to eliminate them, but sometimes if I try to eliminate the critical value part, the entire question will disappear. So if you saw it ask for critical value, just critical value, feel free to skip that a step, because the next step will ask for p-value and your calculator will give it to you on the homework. Okay, so you find p-value. If p-value is small, you reject the null and you support alt. If the p-value is large, you fail to reject the null and you do not support alternative. So what I want you to do, I want you to write this part of the procedure. Please write it out, and then we write a decision with non-technical terms. That's our last step. But I want you to write this one where small, as you see, if p-value is less than 5% or whatever is alpha, then we reject the null and support the alt. If the p-value is greater than alpha, we fail to reject the null and do not support the alt. Maybe write the vocabulary here. We're going to talk about it more. Rejecting the null means we are not, we are rejecting what it says in the null and support whatever is the alternative. Fail to reject the null means we cannot reject the null and we cannot support the alternative. So write these wording. Okay. So we're going to be using these terminologies for the remaining of the semester. And I'm going to keep repeating them probably for a while. Okay. So we don't use table, don't worry about it, but we'll be using our calculator. And again, you remember I said you will not be able to do this course without a calculator. That's the part that it's almost impossible because the procedure of finding it in the table, it's very long. Okay. Given the majority of consumers are uncomfortable with drone deliveries, so imagine that problem was given and I was going to write the steps. So I'm gonna write that on OneNote. Okay, let's just here. Let me go to OneNote. Okay. So if that problem was given to me, here's a step. I do it in 4 steps. Your book is offering 6, 7 steps, but let's say 1, 2, 3, 4. And I want you to write 4 steps anytime you are dealing with any testing from now on until the end of the semester. Testing hypothesis. So I want you to do these 4 steps. Step 1, writing no hypothesis, alternative hypothesis. So when I say show your work and send it to me, I'm not asking for your scratch paper. I'm looking for these step-by-step writing your answers. Step 1, no hypothesis, alternative hypothesis. Step 2 is checking the requirements. Normally, everything has their own requirements. Every section, every testing, depending to what it is. So in this case, in the case of proportion, we have to have minimum of 5 failure and 5 success. 5 success, 5 failure. So 545 were the success because that was in our favor of the question or the claim. And then out of 1009, the remaining would have been failure. What is 1009 minus 545? If anyone has a calculator, so that would be
464.
464. So saying that both failure and success to be greater than 5. That's the requirement. So no hypothesis. In this case, alternative is P. You use P means population proportion being greater than 50%. That's your claim, majority. And then equality of that is the no hypothesis. So no hypothesis always equality. Step 3 is finding p-value. And again, if they ask you for z or t, calculator also gives you that. P-value in this case, I think we got it as 0.005. You compare that right in this step, you compare with 5% or whatever is alpha. If nothing is given, is 5%. But we identified that it's less than 5%. Then that's less than 5%. So we say, and here's, you remember with intervals, we had like some fixed words. Same thing with testing. You would say there is enough evidence so because it's less, there is enough evidence to support, then you would write whatever was the claim to support that majority of people Make sure that those people you are mentioning coming from the population you are talking about, just the not just the um, sample. So majority of people are uncomfortable or are not comfortable with drone deliveries. So here we go. So there is or there is not, depending that if p-value is a small or large. When it's a small in this case, you would say there is enough evidence to support the majority of, and then the whatever is the claim. So I'm going to, the ones that I circled red depends to the outcome of the question. So there is or there is not, in this case there is enough evidence to support whatever was our claim. Majority of people are not comfortable. Any questions so far? Yes, no? Okay. So we'll repeat ourselves many times. Okay. So let's go. That's pretty much the important things that I wanted to be covered in the PowerPoint. Let's see if there's anything else. Finding the p-value, test a statistic. So the associated test statistic here, do you see, was 2.55? That was a large Z. That was a significant Z. That's why P is very small. So basically, anytime again it says critical values, don't worry about it. Let's talk about one tail, two tail, left or right. So if you are saying not equal to in your alternative, then that's called two tail. Not equal to because it comes from either of the two sides could be the way. If it's less, you're talking about that normal graph that we have, about the lower part. And then if it's gray there, then you have upper part. This is the right side of the graph, so we call it right-tailed. This is left side of the graph, so it's left-tailed. And this is both sides, so it's two-tailed. Okay, so just more of vocabulary. We are not using that in our decision making. Terminologies that you will see. Okay, and then p-value. If you want to know what is p-value, I put a nice video on the module. I'll show you which one it is, and I want you to watch that video to get a better idea of what p-value is. But in vocabulary and in the general meaning, in a hypothesis test, the p-value is the probability of getting a value of the tested statistic that is at least as extreme as the tested statistic obtained from the sample data, assuming that the null hypothesis is true. I know the vocabulary is a little bit complicated. Basically, p-value is telling you that if the probability of this thing happening on its own, it's low or high. So when you get a small p-value, that means probability of the event happening on its own is very low. So that means if it's happening by its own is low, then that means it's significant. Large p-value means this event is probable to happen, so it's not significant. But a small p-value means happening on its own is very low, so it is significant. And I suggest that you watch the video that I put on the modules. Okay. So let's just pay attention to this page. So I want you to read this one. P-value, P and P hat. Not confusing this, especially that your calculator doesn't say p-value, say p. TI calculator. For p-value, it says p, but you need to be able to distinguish the difference between the p's. So p-value versus population proportion versus p hat. So these are notations. Please write these notations out. Okay. Critical values, we are not talking about them, we are not using them. So forget about them. Anytime again in the question you see, just put wrong answers and move to the next step of the question where it asks for p-value. And use your calculator for p-value there. Okay. And here is the last step where you write the conclusion. You always need to use simple words. There is sufficient evidence to support the claim that majority of consumers are uncomfortable with drone deliveries. When you write the conclusion, anyone should be able to read it without having any statistical background. So that should be in a very simple words. If you see like articles that they have very technical procedures in the middle, but it ends with a simple paragraph explaining that either they are supporting their claim or not. So that should be in a very simple language. Okay. So never use any technical word in the conclusion. Okay. So this is a good guide for the conclusion. So I'm gonna ask you to read this one because if I read it and go, it doesn't really make any difference in your learning. I give you 2 minutes. So they give you the condition. Original claim does not include equality, and you reject a null. Original claim does not include equality, and you fail to reject, and then so forth. So there are 4 cases. So these are helping you to write the conclusion. So I give you 2 minutes. And when we get to their examples, you're going to see the usage. When the original claim includes equality and you reject a null, means when you are dealing with not equal to for alternative hypothesis. When the alternative hypothesis is not equal to. That's the next 2 cases. For these ones are when it's greater or less, greater or less. Okay, read it, 2 minutes. And I would suggest maybe dedicate a part of your notebook to the calculator commands And also, this is nice to write because it's going to give you some vocabulary of how to write the conclusions. Okay, so the wording for warrant rejection of the claim again is for not equality. Anytime we are dealing with that, which we're going to get to some problems. Okay. Okay, so we're also going to talk about confidence interval again, about proportion and mean. And let's get to type 1, type 2 error, and we're going to go to examples. Type 1 error, take it as vocabulary. Type 1 error is the mistake of rejecting the null hypothesis when it's actually true. With the drone deliveries, we reject the null hypothesis and we supported that, yes, majority. So our null hypothesis was equality, and our alternative was greater. So we rejected the null. We said, no, it's not equality. We are supporting that it's majority. So what if we supported the alternative and rejected the null, where the null could have been actually true? Means half of the people were in favor of drone deliveries and not majority. So we made the conclusion that majority are in favor of not delivering with drones. But then what if we made a mistake? That's type 1 error. When you reject a null and support the alternative where you should not be rejecting the null. And then type 2 error is the mistake of when you say fail to reject a null, when it's actually false. Means, let's say you fail to reject a null, something you had, and you did not support the alternative. Why fail to reject a null? Means you should not reject a null where that's a mistake, where you should have rejected a null. I know there are so many negatives in there. So basically any decision you make, if it's involved of rejecting the null, it's type 1 error, where that could be actually true. And then when you fail to reject a null, then type 2 error, where the hypothesis, the null hypothesis could have been actually false. So I want you to write the vocabularies for type 1 and type 2 errors. when it comes to problems, it may help you to write down the result. Okay, so I'm going to give you 2 minutes, write down the definition and ask me questions. And please write them as we go because you will need them for the homework and for the test. Okay, so now this is a table about it. It says reject a null. It's type 1 error. Fail to reject a null when you have large p-values is type 2 error. And then the true state of nature null hypothesis is true is a correct decision in the in type 2. And then true state of nature null hypothesis is false is the correct decision. So basically any decision you make, remember that could have an error in there. If you reject a null, it's type 1 error. If you fail to reject a null, it's type 2 error. But any decision you make in the statistic could be wrong because you are using samples and that could be wrong. Okay. In the case of, let's look at this example. Can anyone read the question? Can I have a volunteer here?
I'll read.
Please go ahead.
Consider the claim that a medical procedure designed to increase the likelihood of a baby girl is effective, so that the probability of a baby girl is p is greater than 0.5. Given the following null and alternative hypotheses, write statements describing A, a type 1 error, and B, a type 2 error.
Thank you. So, probability of baby girl greater than 5%. So type 1 error is when you reject a null. Type 2 error is when you fail to reject a null. So please continue reading type 1 error. So I want you to be familiar with what they are. So please go ahead. Find them all.
Solution. Type 1 error. A type 1 error is the mistake of rejecting a true null hypothesis, so the following is a type 1 error. In reality, p equals 0.5, but sample evidence leads us to conclude that p is greater than 0.5. In this case, a type 1 error is to conclude that the medical procedure is effective when in reality it has no effect.
Thank you. And please type 2.
A type 2 error is the mistake of failing to reject the null hypothesis when it is false. So the following is a type 2 error. In reality, p is greater than 0.5, but we fail to support that conclusion. In this case, a type 2 error is to conclude that the medical procedure has no effect when in reality is effective in increasing the likelihood of a baby girl.
Thank you. So either of, depending to which conclusion we get to, has a type 1 or type 2 error. Someone asked if I go back to the question, did you mean this part, Shelby? Okay. So they give you something without telling you if it's fail to reject or reject a null, and they say which one it is. So and they say like what happens if it was type 1 error, what happens if it was type 2 error. Okay. So let's now go to another example from, let's take a few minutes break. When you come back, we're going to start chapter 8.2, and that's where you see examples, and I'm going to go to the textbook for those examples. There are not much on the PowerPoint, but we'll be using books examples. So right now is 10:03. Take a break until 10:10, 7 minutes. Walk around, drink water, coffee, whatever you want, and then come back. Recording. Module A2 is all about claiming a proportion. And as you see, I have put some videos in both A1 and A2. Okay, here we go. So key concept is finding p-values and testing population proportion p. And then we're going to conduct a formal hypothesis test about a claim. So here are some of the important things. N, sample size. P, population proportion. P hat, sample proportion, where you have X is partial over total. And then Q is the failure, which is 1 minus success. And that's proportions, of course. Failure proportion. Okay. So these are just notations we are using in this section. So please write them out. Okay. Requirements. We are hoping and assuming that it's a simple random sample. Being a binomial distribution means fixed number of trials, like 1009 in the example of drone deliveries. Trials are independent, means if one person is comfortable or uncomfortable, the next person is independent of the first person. Two success and failure categories means either they like the drone or comfortable with drone deliveries or not. And then the probability remains same. So we said the conditional requirements here is that failure and success to be greater than 5. Sometimes in order to find the failure and success, the numbers are not given, so you multiply n, the total, with proportion. So n, it's total. You multiply that by proportion. So this is a recall from our previous lesson. I'm giving you a minute to copy it down. Okay, we don't need this formula because our calculator will give it to us. We just use technology for p-values. Okay, so now let's go to the textbook and do some problems together. So I want you all to log into your textbook. Go to My Math Lab. Once you're on My Math Lab, just use log into the textbook. Okay. So go to the e-text. Did I pick questions in the modules? Go to module 8.2. Sorry, chapter 8 and then section 2. Testing a claim about proportion. Okay. Go to the exercises of this one. That is page. Let's bring it to the page. Let's do this. Let's do this example for practice, and then we go to the problems. It says, and there are two parts to it, finding the number of successes x. Just use your common sense. Don't look at these solutions. Don't look at the solutions here. A study of sleepwalking was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. What is the actual number? So you have the proportion, you have the total. How do you find the number of people who sleepwalked? So you know that 29.2% of 19,136 people sleepwalked. So you remember we said x is equal to n times p, p or p hat, either one. So x is equal to n, which is 19,136, times 29.2%. In order to put the percent, you need to take it 2 decimal back, or just say 29.2 divided by 100. They are the same thing, which is the same thing as 0.292. 0.292. So use your calculator and tell me what you get. So you should get this number, 5,587.7. You round it up to 5,588. Okay. So now let's do the claim. Ready? Any question here? So next one says, using the same sleepwalking data, the first example, now you want to make a claim. So do you see 29.2%? So now you make a claim that fewer than 30% of adults sleepwalk. Just by sample, you cannot say, yes, that's true. No. You need to know if that's significant enough for the population, if that makes sense. And your sample should be supportive of your claim. So less than 30%, yes, my sample is supportive. Now I need to do the testing. So step one, I want all of you to think what would be P equal to, what would be P less than. Because it says fewer, so fewer than 30%, so you always write it as decimal. And then null hypothesis is always equality. Okay, null hypothesis is always equality. And then alternative is fewer than 30%. Okay. So that's a step one. Step two is making sure that the failure and success is greater than 5. 19,000, so what is it? 5,588 were the success. Hold on a second, give me a minute. Sorry, teaching from home. My daughter didn't know I'm teaching. Okay, so she called me. So here it is. So let's just, you write null hypothesis, alternative hypothesis. you make sure the failure and success are both greater than 5. So here we go. Let me use OneNote for this one because writing on the screen is not my favorite. Okay, so here it is. So no hypothesis. Let me change the color. So here we go. Okay, no hypothesis. Alternative hypothesis. No is always equality. So it's 0.30% or 0.3. Fewer than 30%, you use less, the sign less. P less than 30%. Requirement, that's met. So for the requirement, you would say was 5,588. That's greater than 5. And then the failure would be the remaining from 136. So 19,136 minus 5,588 are those who do not sleepwalk. So do this calculation, it's definitely greater than or equal to 5. Now we need to use our calculator. In this step, you're gonna write me what calculator command you are using. You are using one prop z test. Is not about interval, is about testing. So you find that on your calculator, and then you're gonna tell me what is the p-value. So I want all of you to do this step. Find one prop z-test with just the knowledge you have right now. If you don't know it, don't panic. Go to the calculator command I gave you a little bit before, and then send me the p-values. So email, chat with me the p-value. Go to the calculator, enter the data you have, choose fewer than 30%, and then tell me what p-value you get. And it's totally fine to be wrong. I just want to know where we are. Okay. Okay, I'm starting to receive the answers. So please send me the p-values. P-values is just p without the hat. So that's p-value. Tammy, go back to the calculator command and see if you chose fewer correctly. Same thing with Tegan. See if you got sign correctly. So check the numbers, Shelby. Let's just go here and see. So, or you might be right. So just let's hold on and see what is the answer. Actually, I do not know the answer until I put it to my calculator. So here we go. So let me clear everything. Okay. So stat test. No way. That's not what I wanted. Okay. So I go to stat. I go to test. One prop Z test. 0.3, 30% is no hypothesis. Would you please help me with the numbers? It was 5,588 out of 19,000. What was the rest of the number? 100. Okay, 136. 36. Okay. 136. Okay. So fewer, you choose this option. Less. So the last one is more. The middle one is less. So if that helps, this is for more. This is for less. And this is for not equal to. Okay. Then I go to calculate. Let's see who is right. There we go. So do you see prop? This should be the same as your alternative hypothesis. And then p-value, again, in the questions, they may ask about z statistic, you're going to write it. But to judge, you need the p-value, and that's 0.00. I'm going to write it to 3 decimal places, 8. So p-value, and many of you got it right. Excellent. 0.008. Compare with 5%. That's less. So do I reject the null and support the alternative, or I fail to reject the null? So here's my question. Reject, null, support all. These are hand in hand. Or fail to reject the null and do not support alt. So I want you to decide between the two. It's part A or part B. Which one? Send it to me. So you know that p-value is less than. Shelby, if that came as points that, is that 10 to power? Maybe your calculator is in scientific mode. I'm going to show you at the end how to change it. Excellent to those who are sending it correctly. So when p-value is a small, that's associated with reject a null and support alternative. So that means there is enough evidence or there is not enough evidence. So that means there is enough evidence or sufficient evidence to support that less than, and that's about population, less than 30% of, I don't know what was the question, was about all adults or adult population. So less than 30% of adult population, you started from the sample, now you're writing a conclusion about it. population, adult population sleepwalk. Does that make sense? I hope yes. Any question? If p-value was large, then you would have picked fail to reject a null and do not support alt, and then you would say there is not enough evidence to support. Okay, let's go to the textbook again. Okay, and here are the steps. They write it in 10 steps. 4 steps should be sufficient. Conclusion is important. We say we conclude that there is sufficient evidence to support that fewer than 30% sleepwalked. Okay, so now let's go to another question. Let's do this one. Number 3, example 3. I want you this time to write null hypothesis and alternative hypothesis. Read example 3 here. I want you to write null hypothesis and alternative hypothesis. And try to not look at the answers, please. So write a step 1, null hypothesis, alternative. Read the question. Example says in testing a method of gender selection, 10 randomly selected couples are treated with the method. They each have a baby, and 9 of the babies are girls. Use a 5% significance level to test the claim. So this should be a word to tell you that this is a test and it's not interval. To test a claim that with this method, the probability of a baby being a girl, is greater than 75%. So you use the claim and you write it out. So you're gonna go to your paper and you're gonna write me the steps. Okay, so that would be null hypothesis, alternative hypothesis. Did it say more than 75%? I think so. And then you can always use the alternative to come up with what the null is. They are the same. One is equality, null is always equality, and alternative is whatever the question is. Okay, checking the requirements. So what was the requirement? So the requirement was checking 5 successes and 5 failures. Let's see if that's met here. So X was 9 out of 10, so success. And then failure, they were out of 10, so 10 minus 9 is 1. So that's not greater than 5. So right here, the failure, success is met, is greater than or equal to 5, but failure is not. So the requirement is not met. If the requirement is not met, doing the rest of the problem is worthless because the requirement of the problem is not met. So then doing the rest of it would not be giving us much of information. Okay. But if you were finding the p-value here, you would have find it, but again, it's not valid when you are not having a correct requirement. So let's just do some, so then you would say the requirement is not met. So now let's just go do some problems. Mikey D's. Okay, I want someone to read number 10 for all of us. And then we're gonna write down no hypothesis, alternative hypothesis, beginning with that, and then checking requirements and so forth. Can I have a volunteer to read number 9? That would be a break for me to not read every single question, and that would be a break for you to not listening for the entire time. I'm waiting for a volunteer to read number 9. Anyone interested? Thank you. Indamala, go ahead, please.
Okay, Eliquis is used to help prevent blood clots in certain patients. In clinical trials, among 5,924 patients treated with Eliquis, 153 developed the adverse reaction of nausea based on data from Bristol Myers Squibb Co. Use the 0.05 significance level to test the claim that 3% of Eliquis users develop nausea. Does nausea appear to be a problematic adverse reaction?
I see you read number 10. That's fine. Let's do number 10. And then we're going to go back and do number 9. So all of you on number 10, thank you so much. Let's just on number 10, all of you write no hypothesis, alternative hypothesis, and then check the requirements. That's a step 1 and a step 2. And I want you to send me, tell me what do you have for new hypothesis and alternative through chats. Okay, time is up. So number 10, write me no hypothesis, alternative hypothesis. Okay, so I see some answers coming. Let's just go to, so far no one got it exactly correct. Let's just go here to OneNote. So help me to write down, so just the claim itself, no hypothesis, alternative hypothesis. So in the question, the last sentence that helps me to form the known alternative, it says the test to claim that 3% of the users develop nausea. So that means exactly 3%. It doesn't say less than 3%. It doesn't say more than 3%. It's telling you the equality. So equality, even if that's our claim, goes in the null. And then alternative to equality is not equal to. Because it didn't say more, it didn't say less, it said that exactly 3%. Sorry, 3%, not 30%. 0.03. 0.03. Does that make sense? So it didn't say more, it didn't say less. That's where you use not equal to. Sometimes it says is not equal to 3%. That's also you use that. But then even if it says equal to, then alternative to that is not equal to, because they didn't say less, they didn't say more. So now that was a step one. Step two, checking the requirements. So X, the number of success is 153. So that's the success. It's greater than 5. Failure should be very large. It's definitely greater than 5. 5924. 5924 minus 153 are those who did not develop nausea. And that's definitely greater than or equal to 5. Whatever that number is calculated, it's obviously greater than 5. So the requirement is met. Step 3, now you want to find p-value. You would tell me that I'm using one prop z-test. So I know what you're using. And then now I want all of you to send me p-value. So please use your calculator, plug in appropriate numbers, plug in the correct null and alternative hypothesis, choose a right one out of this, this, and that. Choose the one that is correct. And then send me what correct p-value is. Okay, I'm receiving some answers. Just make sure out of the 3 options you are choosing not equal to. So pay attention to that because we didn't say greater, we didn't say less. Let me enter the answers with the numbers with you. So here we go. Go to the calculator. Okay, so here we go. Here we go. We go to stat. We go to tests. We go to, oops, that's not what I meant. So we go to stat. We go to tests. We go to one prop z test. And then we had 0.03. And then help me with the numbers. What is x and what is n? So x 153, okay, n. So 153 is x. What is n?
5,924.
5,900.
924.
Thank you. And then you choose the option of not equal to, and then you go ahead and calculate. Okay, so here is the p-value, 0.0597. Two or three decimal places would be sufficient. So let's say 0.06. So you would have p-value is 0.06. Did they say compare with 5% significance? Yeah. So comparing that with you could have write more decimals. 0.06 is greater than 0.05. So out of the two options of reject a null, support alt, or that's A, or do not or fail to reject null, that's part B, and do not support all, which one do you say, A or B? Which one is the case? Very nice. Many of you are responding correctly. So that is fail to reject a null. And again, that's associated with large p-value. So p-value is large because it's greater than 5%. So then in this case, you would say there is, so in this case, you remember I said when you have inequality, as I asked you to write it in the PowerPoints, we said when we got to writing the conclusion, think of there is not enough evidence or sufficient evidence to warrant rejection of the null that exactly 3% of, then you write the claim that exactly 3% of people experience nausea. Okay, so there is not enough evidence to warrant the rejection of the null that exactly 3% of people experience nausea. Any question? To use the warrant rejection of the null when you have the inequality. Any question? So what we gonna do for today? So we still tomorrow we're gonna go over 8.3. So I wanted to spend good amount of time in 8.1 and 8.2 so you get the idea of testing. Tomorrow we're gonna talk about testing about population mean, and then we also gonna start chapter 9. So from this chapter on, the concept again is either testing or the interval that we had last time, like we are 95% confidence that the true whatever population proportion, population mean, so forth falls here. Or it's going to be test that there is enough evidence, there is not enough evidence to support whatever that is. So basically, from now on, that would be our main concern with different calculator commands and different contents. So I'm going to put the homework up for chap 8.1 and 8.2. I'm going to put it also for the following, if next few homework up, but then please do 8.1, 8.2 as soon as you can. Chapter worksheets are always up. We are not completely done with chapter 8, so some of those questions you may not be familiar with. But again, tomorrow 8.3 and probably 9.1, maybe 9.2. That's pretty much it. And again, I'm gonna put my math lab work up so you can get us started with 8.1, 8.2. Do the things daily as again, this is a summer semester. Things move very quickly. So that's all for today. Have a great time.
Thank you, Professor.
Thank you.
You're welcome.